welcome to another video by Geordie Shed, and today we're going to be testing out the hydrogen generator. Let's get started. So here's the hydrogen generator that we built in the last video, and as you can see I've attached the bubbler, which is this thing here. So all this is we've got the pipe that comes out the hydrogen generator going down into some water, and then there's a shorter pipe going in where the hydrogen comes out. So this stops anything going back into the generator and only allows hydrogen to come out. So it's a bit like a one-way valve. So I've also put some glue around the attached terminals. This is to try and make it a bit more airtight, because it's not the most airtight in the world. So hopefully that'll help it a little bit. So here's the hydrogen generator, so we can put that to one side. First of all, what we're going to do is we're going to fill up this this container with some distilled water. So there's a bit of water already in here, so I'm just going to dry that. And now our container's dry, we can now fill it with distilled water. So this is distilled water, and the reason I'm using distilled water is because other people who tried it said if you just use regular water, then the impurities in the water, such as minerals and stuff, can corrode the plates. So I'm using distilled water, so hopefully that won't happen. So if you're wondering where I got this from, I got this online, and it wasn't much actually. It was only about £3 I think for a litre. So now we're just going to fill this up. So it's just over the top of the plates. There we go. I think that's enough. So now for the dangerous bit, I suppose. So here we've got a 1 kilogram tub of potassium hydroxide flakes. So we're going to put a teaspoon of this in the water. But my teachers at school seem to think that this is the most deadliest thing ever and I'm going to kill myself. So we're going to put on some adequate safety equipment. Okay, so for the first layer of protection, I've duct taped some gloves, protection gloves, to my boiler suit, so there's no way that the potassium hydroxide can touch my skin, because it's alkaline, and if I got it on my skin it would probably burn me if I didn't get it off quick enough. So this at least will stop it getting on me straight away. So if it gets on me, then I can quickly take all this off and then jump in the shower to get it off. So the next layer of protection I'm going to use is I'm going to put another pair of gloves over these in case they split. So now I have my 2 layers of gloves on. So these are black, so the second they split I'll be able to see blue and I'll know and I can stop and deal with it. But the main problem, well, only one of the problems with potassium hydroxide is that it's highly alkaline and it'll burn your skin. But the other one is that if you breathe it in, it will damage your lungs, and if it gets in your eyes, then it'll damage your eyes. So now what we're going to do is we're going to remedy that. But just before, this is not 100% potassium hydroxide, which is really bad. This is I can't remember what it is, but it's like 95% or something, which isn't quite as bad. So it's not as dangerous. So now what I'm going to put on is I'm going to put on some head safety protection.
Okay, so at this point I think that I'm pretty safe and I'm not going to die. So now let's get on with doing the experiment. So here's our pair, I can never remember what this is called. Potassium hydroxide, that's what it is. So we're going to carefully open the lid. And then we're only going to start off by putting a small amount in the water. So we're just going to get a small teaspoon of flakes like that. Very carefully place it into the water. And now we're going to close the lid We're just going to leave this to dissolve. Okay, so now the potassium hydroxide has dissolved into the water. We're now going to put the generator into the water slowly and carefully. We're going to tighten the lid. Okay, so there we go, that is the generator assembled and ready to go. So now it's the moment of truth, time to actually power the thing. So how I'm going to power it is, here I've got this PC power supply, and I've wired the green wire which turns it on to ground, so the power supply will always be running. So now if we plug it in, we should get 12 volts off these two wires here. I'm just going to plug it in. And I've got my multimeter here to test that it is indeed 12 volts. We're now getting some current flow. So at the moment, the garden generator is taking 0.94 amps, so 940 milliamps. So at the moment, the level of hydrogen production isn't that high. So what we're going to do is we're going to add a bit more potassium hydroxide to make the solution more conductive, so more current will flow, and then we'll try again. Okay, so now for the moment of truth again. So we're going to connect that up. Now it's pulling 3.5 amps, and we're getting a lot more bubbles from the generator. Yeah, so we are getting a lot more bubbles now, but still not enough, and I think that part of the problem is that the generator isn't sealed tightly enough to force all of the gas into here, but then I don't think there's enough gas going through to stop that anyway, because this isn't going through. So we're going to add some more potassium hydroxide, because this power supply can do 13 amps and we're at 3. So we've still got a lot left to go. So I'm going to do exactly the same as I have done and put some more in. Okay, so I've added some more potassium hydroxide. So now let's try again. So we've got 7.5 amps flowing, and we're now getting bubbles out of the bubbler. So that is good. That means we're producing some form of gas. By the looks of it, we're producing it at a fairly decent rate. So that's a good start. So I'm just going to disconnect it. And now what I'm going to do is I'm going to get an empty plastic bottle and place it over the top of the output. So then we'll be able to collect the hydrogen and test to see if it actually works. Okay, so I'm back with a nice bottle. And what's quite interesting is it's still bubbling. I think that's because the bubbles are still being released even when the electricity stops, because the bubbles tend to stick to the plates. So then when you remove the electricity, they carry on stopping. I think the power supply is cut out, so I'm just going to put the bottle on here so we can start to collect the hydrogen. I'm just going to restart the power supply. There we go. The power supply seems to not wanting to deliver this much power continuously. Although it's rated for 13 amps on the 12 volt line. So, I don't know. Yeah, the power supply is just instantly cutting out. So what I'm going to do now is I'm going to use a car battery and try that instead. So I've got the car battery set up here. So now I'm just going to connect it up and see how much current we get. We get an 8.5 amps. It's now bubbling quite a lot. And the water's also starting to turn dark, which is interesting. So anyway, that should be enough to at least test if it's hydrogen or not. So we're going to lift off this bottle. I'm going to stand it like that. And now I've got a lighter, so now it's time to ultimately test it. Oh! So I think that's safe to say that it works. So now I'm going to carry on making some hydrogen. So what's interesting is that the hydrogen generator is starting to turn this darker colour, and I don't really know what that is, to be honest. But the rate of hydrogen production is pretty good. So at the moment we've got 7.7 amps, but when you first plug it in it's at 8.5, so that's probably why this power supply was dying, because the initial current inrush tripped it, and it trip it every time. Okay, so this has been bubbling for quite a while, so it's now time for another test. Woo! So the heat from that one melted the bottle. Because it got that hot. So we're going to carry on. So see, that went up to 10 amps. And I just plugged that in, so that's why the power supply was tripping.
So it's been bubbling for another 10 minutes and it's still not showing any sign of stopping, and it's heating up, which is quite the issue. So I'm quite glad that I've put it outside now. So it should still be producing hydrogen, or I presume it still is. So the bottle's been on there a while, so we're going to try and light the bottle once again. Wow, so that was quite exciting, and it's still going. So this is about a good 15-20 minutes after I unplugged it from its power supply, and it's still running. So don't really know what I've created here. This self-sustaining hydrogen generator, if I was going to put a clickbait title, but it's clearly not that. So if anyone has any idea what's going on here, then you might want to drop a comment in the video description. But so what I could do, what I thought I might do now is I might put this in a bucket of cool water to try and cool it down. But I thought well, might as well just leave it and see how well it goes and how long it runs for, because I think this is quite an interesting experiment, and I've learnt a lot from it. And you never know, this might be the next green energy thing, a self-sustaining hydrogen generator. Although, as I said, I'm pretty sure it's not that, and something's going on. I'm presuming that it's a reaction between the plates and the potassium hydroxide, because it's forming a black precipitate, and it's an exothermic reaction that's producing hydrogen, and I presume it's producing oxygen as well. So we'll just see how long it lasts for, pretty much. Okay, so a bit of a status report on the generator, and that it's still running. If we look down at the bubbler, we can see that it's still bubbling away, and the generator is fairly warm. So I feel it's not too warm, but I'd say it's about 30 or 40 degrees, and it doesn't seem to have changed temperature in a while. But if we try and look closely at the generator itself, I don't know if you can see this on camera, but there's a cloud. I presume it's, I don't really know, I'm not a chemist, but there's something in the water that's obviously, I don't know if it's a precipitate or if it's the tin sheets like disintegrating in the water. But the colour doesn't seem to really have changed, and I can't really tell if the stuff's settling at the bottom. So I don't really know what's going on here. As I say, if you do know, please hit me a comment or message. But I think this is really interesting. So now what I'm going to do is I'm going to light the bottle and see if it's still explosive, I presume. Come on, lighter. Woo! So that was even better than the previous one, because I couldn't see a flame and the reaction happened very quickly. So that means there was oxygen in the mixture as well. So we're just going to put the bottle back on and continue with the experiment. Okay, so it's now a good 45 minutes, 50 minutes late after we first did it, and it's still going. The temperature seems to be remaining fairly constant, and it's getting fairly cloudy, and by the looks of it, it looks like the stuff, the precipitate or whatever it is, the particles, are moving up the centre and then coming down the outside, but it's a bit difficult to tell. So once again, we're going to test if the gas, how explosive the gas is. So this is, I think this has been probably a good 25 minutes since the last time we did it. So this bottle should be fairly full. So then we're just going to do exactly the same again. Wow, that was exciting. So the bottle actually launched all the way, well, I say all the way, it's not really that far, but it's still a distance. So I'm just going to put the bottle back on here and then leave it even longer. And hopefully the reaction's going to stop soon, or I'm going to have to stop it myself. So I'll see you in a bit. Okay, so it's been about 10 minutes since I put a bigger bottle on. So this is a 1 litre bottle. So I thought, well, maybe we can collect some more and have a bit bigger of a bang. So I think the rate of hydrogen production is starting to slow down. The generator is a little bit cooler, I think. It's probably about 20 to 30 degrees. But when I swapped the bottles off, I lit the smaller one, and it hadn't been going for as long as I've been leaving it before, and it went with quite a bang. So I thought, well, we'll try and do it with less hydrogen in it, so maybe we're running too rich. So now we're going to take this off here, place that on there, and then same again. So that wasn't very exciting, was it? So I don't think there was quite enough, considering it's a lot larger bottle and I've only left it for about 5 minutes, and hydrogen, the rate of hydrogen production has slowed down quite a lot. So in fact I'll show you this now. Okay, so finally the reaction has stopped. So this is about an hour and a half after the last update. So this is about a good 2.5 to 3 hours after I unplugged it from the power supply that it's finally stopped. So now I'm going to take it apart to see what's going on inside. So obviously I'm not going to do this in the shed because I don't want a hydrogen sodium hydroxide solution all over my shed. Whatever the chemical is, I can never remember its name. So first of all I'm going to unscrew the bubbler. Potassium hydroxide, that's it, not sodium hydroxide. So there we go, there's the bubbler, which is slightly dark in colour. Well, the water, not the bubbler itself. And now for the big reveal. So it's still a bit warm, but not too warm, probably about 20-25 degrees. So as expected, the generator has completely disintegrated. And the plates are extremely clean. I don't really know how to describe it, but they've like obviously been dissolving, but they're like really smooth. So if we pull out the rest of the generator, you might actually be able to see the steam coming off the water. It's a similar story. All the plates have been like polished almost, and the brackets haven't actually melted, but they seem, I don't know why, but they've all broken. So I don't know if they've snapped or just melted and fallen apart or what's going on. So I might have to investigate what's happening here, and then obviously create a new one. So these are all the generator plates or cells, and they're fairly intact, so I probably could use them again, but I'm not sure what's going on in the reaction, because it's not quite what I was intended. Because if you do this experiment with stainless steel plates, the water should stay clear and just produce hydrogen. So the water is fairly warm, but it should be cooling down. So I think this has been quite an interesting video. So if you enjoyed this video, please like and subscribe, and even share it, because the more views I get, the more likely I am to do this again. Thanks for watching. Bye.